From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 237, recorded live Thursday, October 21st, 2010. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott delves deeper into the Netduino with Chris Walker.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. And today we've got a very special guest, Chris Walker from Secret Labs, coming on to talk about a new Netduino project. We talked to Colin Miller a little bit a few weeks ago about what the .NET Microframework is. And now I wanted to go straight to the source of some hardware and talk to Chris. How's it going, sir?
Good. Hi, Scott. Good to be on the show.
Very, very cool. Thank you for taking the time. Before you tell us what you've got cooking over there, I want to dig in a little bit on what exactly you're building, how you built it, how you got the idea, and how this relates to Arduino. So maybe you can give me a little history.
All right. No, very good. Arduino, for those that don't know, is this really cool open source 8-bit platform that you can use to build projects. There's a lot of artists who build electronics projects from it. That's really kind of the genesis of it, but it allows people who have never done programming or never done electronics before to hook up motors and lights and things like this to a microcontroller and to build things. So Netduino is kind of the next generation or the extension of that idea, open source community electronics, but using the .NET Microframework, this really powerful platform which allows you to build even bigger projects, more sophisticated things at about the same price.
How is that possible at about the same price?
Microcontrollers come down in price over time, and we've lived in a world where we had 8-bit computers, and then we switched to 32-bit. Well, this is the year where we're starting to see some transition from 8-bit microcontrollers, those things that you have in remote controls or baby monitors or pedestrian stoplights, the low end of the computer processor spectrum. We're seeing the spectrum of those to 32-bit as well. And by using the .NET Microframework, we make it very simple to program those processors. So costs coming down, and the .NET Microframework have kind of created this perfect universe where we can now start moving to that 32-bit world.
So tell me about what's on this board. People can see this if they go to netduino.com, and there's some other hardware vendors that create similar boards. What's on this little board?
All right. So on this board, you have a microcontroller. The difference between a microcontroller and a processor, which would be in your computer, is that these are very low end. They're still 32-bit, but they have like half a meg of storage space and 128K of RAM. So they're like a 386 from years and years and years ago. But on this board, you have a push button. You have a bunch of connections where you can plug in wires. You have a USB port, and you have a power plug. Effectively, what you do with this board, it's the brain of your next electronics project. So you're going to plug a motor into it. You're going to plug an LED into it. You're going to plug a push button or a Zigbee radio into it. But it's basically the base board that everything gets built from. And like you mentioned, it's actually designed in the Arduino form factor. So our attempt was to make it 100% compatible where possible with all of the Arduino accessories out there, which means that there's a ton of things you can buy and already plug in and support the existing open source hardware community at the same time.
Okay, so assuming that I don't know anything about hardware, I know a little bit, I know enough to be dangerous, but let's assume that I and the listeners don't know anything about that. We've got a different processor, we've got a different kind of core firmware and operating system for this little platform. What is it that is compatible? How can you say that that's compatible with the daughter boards from Arduino? Are we compatible at the voltage level, or at the, what specification are we compatible with?
At the pin and communication level. So actually, let me go into that a little bit. On the Arduino boards, you have about 20 different what are called pins or connection points where you can hook in wires or LEDs, et cetera, et cetera. In those, you have a few different communication protocols, a few different ways you can do things. You have something called PWM, which makes waves that can change the intensity of a light or can drive a motor. You have something called SPI, which is a communication protocol that's similar in some ways to a serial port on the computer. You have something called I2C, which is another communication protocol that you can daisy chain multiple devices together. On the Netduino, the ARM processor on it isn't like the AVR 8-bit processor on the Arduino. So we actually added special circuitry on the board so that those pin connections, which you can plug those shields into, are all at the same place logically, so that when you get one of those accessory daughter boards, it will work on the Netduino. You might need to create a driver. There is a voltage issue because 32-bit is 3.3 volts, whereas 8-bit was primarily 5 volts. But the Netduino digital pins can also accept 5-volt signals without damaging the board. So most cases, things just work.
Okay. So let me see if I can translate a few things for people who may not be native English speakers or may not have be hardware enough people that they understand what you said. You've used the term daughter boards. You've used the term shields. Is that the shield is what the Arduino guys call these little additional boards that you stack on top of the main board?
Yeah, that's exactly correct. In the Arduino community, one of the really cool things about open source hardware is because all the specifications are public, there's a large group of people who have created innovative ideas on how to expand the platform. And so they've created what they call shields, which are expansion boards which stack on top.
And when I make hardware open source, like if I make software open source, I release the source. But with hardware, I assume I release a PDF of what the board looks like, or what do I release if I'm going to make a shield that I want to work with a Netduino or an Arduino?
So for open source hardware, you don't have to make your hardware open source to make it work with the Arduino or the Netduino or any of the open source boards. We love it. The community does a lot of it. But to make your board open source, effectively what you do is you publish the source. And the source comes in two forms. One is your schematics. Some people publish as PDFs. Some people publish in a binary data file, which can be converted into a visual representation of the electronic circuit, like a PDF. And then the other is the board design file. If you go to netduino.com, you go to the downloads page, you can actually download the board design file, which you could send off to a board manufacturer. They would actually make you a board which looked like an Netduino. And if you had mad soldering skills, you could actually put one together yourself.
Oh, wow. So I'm looking at this PDF here. It's a big 8.5 by 11 PDF. Looks like just one page. And this is the description of what I would need to build my own Netduino board.
That's exactly right.
And it's totally open. What is it licensed under?
So the license on all of the board design and schematic files is something called Creative Commons Attribution. And what that means is you're welcome to use it. You just need to say, hey, this was inspired by Netduino. But it's royalty-free. You can use it in your projects. And if you do build something with your Netduino that you want to go and turn into a commercial product, you can take our design files, integrate them into your own product, and go off and build something and sell it in the world. You don't need to stick a Netduino inside each box.
Okay, so the board has these pinouts, these little blue pinouts, and one says digital I/O and one says analog in, and then there's a power block. Is that called GPIOs?
So GPIOs are the digital pins. On the Netduino, we advertise that 6 of them are analog and 14 of the pins are digital. In reality, all of them can do digital. The analog pins will also do digital. GPIO means general purpose input and output.
Now, you said I needed to write a driver, though. Now, it's scary enough that as a software guy, I'm going to start doing hardware. But then you said I have to write a driver for something, and that got really scary because from my perspective, writing a driver in Windows might be, extremely low level, and it has to really conform to some specification for drivers. But I think perhaps you might mean something different when you say driver in the Netduino world.
Yeah, in the .NET Microframework world, in the Netduino world, driver is a much simpler thing. If you are hooking up an LED to a pin on the Netduino, you simply say, turn this on and off. That driver is already built into the microframework. It's an object called output port. If you hook up a push button and you want to sense when someone pushes it, you use an input port. If you want to control a motor, you use a built-in driver called PWM. All those things are built in for most of what you do on a day-to-day basis. What you'd create drivers for are things like a GPS sensor. And really, when we say driver for a GPS sensor, what we mean is parsing the GPS messages to pull out your location. The good news is there's a huge community of people building Netduino drivers, parsers, all this stuff today. And you can download a lot of them right off our community forums.
Ah, okay. There's a push button on this thing. And while I could get a shield or I could do a daughter board, what if I just wanted to plug in an LED? What if I just went to Radio Shack and got an LED with, 2 little wires? Can I just shove those 2 little wires into one of these I/O ports and suddenly I'm good and I can make it so I can push the button and that light will turn on?
Yeah, actually you can. 2 things there. One is that the push button on the Netduino can function as a reset button or a push button that you can use in your code. And there's also an LED built onto the Netduino. So you can actually create a program, your first Netduino app, blinking that light, tapping out Morse code, making your own little one light version of Simon, which someone on the forums actually did, using the Netduino itself. By simply getting an LED and plugging it into one of the pins and then into one of the ground headers, you can now drive an external LED without changing your code at all. All you have to do is say, use that pin instead of the onboard LED.
When I start doing this, I've got Visual Studio installed, and I just plug the Netduino in via USB. And are there drivers to install? Can you kind of walk me through the process?
Yeah, so the setup process is pretty straightforward. First, you're going to need Visual Studio. All of the commercial versions work, and Visual C# Express 2010 also works beautifully. So once you have your development environment installed, you install the .NET Microframework SDK, and then you install the Netduino SDK. With the Netduino SDK, it automatically takes care of all the drivers and all the libraries for you. So when you start at Visual Studio, you just create a Netduino app, and you're off and running.
Okay, and then when I'm in my main, there are these classes for output port and then input port. How do I hook those up to the pins? I mean, is this pretty low level? I mean, I need to go and say pin number 1 is the input port that I'm interested in and things like that?
So this is C#. This is .NET. So to blink an LED, for instance, you're going to create an output port object, and that's as simple as typing output port LED equals new output port, and then you tell it which pin you want to use. That's all you need to do to hook it up. And then you say LED.write true to turn it on, or LED.write false to turn it off. This is very similar to what you do on the desktop to print a line to the screen or to send a bit of data.
And like we heard with Colin last week, it's a really tiny but real little CLR. It's got garbage collection and memory, and it behaves exactly like you'd expect. In the couple of projects that I've worked on, you hit F5 and it really debugs, and you're stepping through it, and you've got a call stack, and you've got local watches. It's creepy, and it's amazing.
Well, that's exactly right, and you've hit on something right there, which really differentiates this from the 8-bit open source electronics world. 2 things. Number 1 is you have powerful tools and a real debugger. If you take someone else's app, someone else's project they've built, you can pause it. You can step through it. You can learn how things work. And then as you create your own sophisticated projects, when you run into a bug in your system, you can just set a breakpoint, and you can analyze what's going on in the system. And you're not trying to write out print statements through a serial port and diagnosing things through hyperterminal. The other side of that coin is you are using Visual Studio. And with, for instance, the Netduino Plus, you can create an Azure app in the cloud and a Windows Phone app, or frankly an iPhone app, because it's platform agnostic from a communication standpoint, and then a Netduino Plus app. And you can have a whole world of things talking using the same code written in the same environment, and you can debug all of them.
Hi, this is Scott, coming to you from another place and time. Are you using agile practices to manage your software development? There's lots of tools on the market that manage the steps of a project, but most of them focus on individual roles. Get ready for a solution that caters for the success of the whole team. The guys at Telerik introduced Team Pulse. It's an agile project management tool that'll help you gather ideas, estimate, plan, track progress in a common workspace. Finally, companies, regardless of their size, can use a lightweight and convenient tool that makes all the stakeholders work as a united team, even if they're in different countries. By combining intuitive user interface and the power of Silverlight, Team Pulse removes the roadblocks that you typically face and applying Agile in an effective manner. No more lost data, no disparate systems, no lack of critical analytics regarding the health and velocity of your project. See for yourself. Get a free copy for 5 users and 1 project at Telerik.com/TeamPulse. And please do thank Telerik for supporting Hansel Minutes on their Facebook fan page, facebook.com/TELERIK. Telerik. We do appreciate it. There wouldn't be a Hansel Minutes if there wasn't Telerik helping us.
Okay, so juxtapose the difference between a Netduino and a Netduino Plus.
Okay, so Netduino and Netduino Plus. The basic difference is the Netduino Plus adds integrated open source networking, which is also pretty exclusive here. In the 8-bit world, you can't do that. And it also adds a micro SD slot so that you can store data.
Wow, and the micro SD could be gigs. I mean, I could have like a sensor array that could be collecting information and could just dump it onto the SD card.
Absolutely. You can put a 2 gigabyte micro SD card right in there.
Wow, and I'm using Netduino's specific file access, or am I using system.io?
You are using system.io. It's just like you were using the desktop .NET framework.
That's pretty cool.
And for networking, it's exactly the same as well.
I've always kind of wondered if this was a secret that Microsoft was keeping. Like, it's a pretty small team, right? I mean, do you call Colin and the guys on the .NET Microframework team and just chat with them, or is it different than working with other people at Microsoft?
Yeah, so the .NET Microframework team is pretty cool. It's a small group of people, and then they have some other people that work with them. But in addition to that, there's what's called the core .NET Microframework team, and I was actually honored they invited one of us from Secret Labs to join. But a couple of companies have representatives, and like a traditional open source project, a lot of us are contributing code and checking things back into the core. So when we make a tweak to .NET Microframework, let's say, for the Netduino, you'll actually see those roll back into the main code base and benefit any high-end .NET Microframework boards, the 800 megahertz video decoding ones, whichever one's out there.
Wow. Have you personally, or has you and your team changed the framework in some way? Have you checked in code that is now shipping with the framework?
Yeah, absolutely. Actually, in the QFE1 update, we worked with the .NET Microframework team to find a bug in the core, and that was actually checked in. During the development of Netduino, we were actually pretty active, and I don't want to take much credit for our team of helping drive the .NET Microframework because we might help with 0.01% of the code. The guys at Microsoft spent years making this thing. It's a pretty amazing platform.
Was it a big deal for them to take takebacks? Because I mean, I really try to push open source, but I work in the web stack, and we're slowly turning this ship around, and being able to take takebacks will be a big deal when we start doing it on a regular basis. Do you have any idea how they're pulling this off? How they're able to do this so smoothly?
Open source at Microsoft's an interesting thing. People have traditionally looked at Microsoft as a company which doesn't give things out. Or if they give things out, they're not giving you the source code. There's a special license to it. There's been a lot of misconceptions of intent, I think, in the past, or maybe not. The reality of the situation is that Microsoft has started adopting what's called the Apache 2.0 license, which is an industry standard open source license. .NET Microframework uses it, Iron Python uses it, but what this allows us to do is use the Codeplex website at Microsoft to do open source projects just like a traditional open source project like Linux. There's still control over the project. Every project has its leaders and people that approve check-ins, et cetera, but we can go to Codeplex and simply submit code.
That's pretty cool. I hope that it's like that with most things. That's my goal. That's one of the reasons I came to work here, was to make sure that everyone could do that. And it sounds like it's slowly but surely we're gonna make it happen.
Well, in the .NET Microframework 4.1, there were entire classes that were donated. Some expanded collection capabilities, for instance, were donated by members of the community.
Yeah, I mean that's the way it should be, right? It should be more than just bugs. It should be an ongoing collaboration, I think, with the community. Yep. Now, you were gonna announce something today. You've got the Netduino Plus that adds networking and adds the SD card slot. But you've got something that you've been cooking up.
Yeah, so we have a little surprise today. It's a new product. Actually, we have two surprises. The first is for that Netduino Plus book, there's that Netduino Plus board, there's actually a book coming out called Getting Started with the Internet of Things, published by O'Reilly, which we'll be putting sample chapters of that on our website, netduino.com, in the next week or two. So people can check that out and see how to build Internet-connected devices using .NET Microframework that can also talk to .NET apps on the desktop. That's cool. Surprise number one. But surprise number two, which I think you're alluding to, is a new Netduino. It's called the Netduino Mini. And it's it's like 0.72 square inches version of the Netduino that you can not only plug into a breadboard to do traditional electronics design, but when you create something with your regular Netduino and you want to go to market with it, it gives you a really inexpensive, tiny little chip you can solder into a simple circuit board and make real products.
Okay, wow. Okay, so let me see if I understand this, because the Netduino itself, the one that we play with, with the kit, is what's the size of this thing? It's like 3 inches by something. It's like 2.1 by 3 inches.
Yeah, absolutely. It's 2.8 by 2.1.
2.8 by 2.1. So you kind of visualize that, folks that are listening. And you might say, well, now I've got it working, and it's kind of this Frankenstein prototype. How am I going to shoehorn this, 2 inch by 3 inch thing into my project? How big is the Mini?
It's an inch. It's just over an inch long and 0.6 inches wide. It's 1.2 by 0.6 inches. It's the exact same size as a standard 1.2 inch DIP microprocessor chip, like you might see in an electronics product today. It is tiny, tiny, tiny.
Wow. Okay. And does it have the same 32-bit microcontroller? It's still 48 megahertz, and it's an ARM, and it's got the same storage and RAM as the bigger one?
It actually does. It's the exact same processor, and it's in a different size of what's called a package. In order to fit it onto this size, we had to use a little more expensive version of the microcontroller. But you actually get a little bit more RAM. Because it's a microchip form factor, or a DIP chip form factor, it doesn't have USB on it. It has an RS-232 port. Well, that saves us a little bit of memory, so you actually get 4K extra space.
I think that's just such a different world, the idea that it's 2010 and that people will rejoice in that extra 4K, because I'm sure that the people who are listening are like, yes, the 4K has arrived. And I can,
that's exactly right. Well, in the 8-bit world, you only get about 2K of RAM on most of the chips. So the fact that we started with 60 and now we're going up to 64, it's like we doubled what you used to have right there with 4.
That's awesome. So like I'm looking at my the electronics products that I have all over my desk here. I've got my Jawbone Bluetooth headset. I've got my electronic watch. I've got my M-Audio MicroTrack audio recorder. And I'm realizing that all of these consumer electronic devices are smaller than the original Netduino, which makes sense for hobbyists. But the Netduino Mini will fit in any of these, even inside the Jawbone tiny Bluetooth headset. So you expect people will make commercial products with this?
Well, yes and no. Yeah, absolutely, yes. But there's actually 3 markets here for the Netduino Mini. A lot of educators like teaching with the traditional microchip DIP form factor as an actual teaching aid, so people are learning at a more raw level how these things work. You also have the commercial world, and we already have some test customers who are playing with the Netduino Mini and are looking at putting it into testing apparatuses, products, etc. But, for users who are using Netduinos and building things, making UAVs, making a lot of different projects, Netduinos, even though they're small, are still too big. And something like a Netduino Mini, which is almost weightless, it's so light, just makes the perfect hobbyist product as well. And it's less than $30, so it's kind of a no-brainer just to pick one up.
Wow, that's cool. Well, very cool. Congratulations.
No, I'm excited to talk about it on your show. This is going to be a surprise to a lot of people.
I'm glad. So tell me about some of the cool things that people have built. Because I'm still trying to think about what I could build. I've been doing some basics. I've been learning. I've done, Morse code, and I played with some Arduino stuff, hooking up an existing old RS-232 piece of hardware, and I'm trying to think about how I could move that over to an environment that I'm more familiar with. But tell me about some of the projects that people are building.
Oh, absolutely, and this is what gets me most excited. As much as Netduino is a product and a microcontroller board you can use to take your .NET skills and apply them to electronics, it's a community of people building really, really awesome projects, and we like to celebrate those. First of all, go to the projects page or the community page on netduino.com, and you'll see some of the stuff people are building. But since you mentioned it, let me name a few of them that I personally love that people have built already. How's that?
Okay.
So one of my favorites is actually a Morse code decoder. The projects range from what people call pointless to really cool. And community member Hari built a Morse code decoder. Someone had created an app which took strings of text and blinked them out via the LED on the Netduino in Morse code, old school style. So Hari saw that and said, I'll one-up that. And so he took a light sensor and a breadboard and a Netduino and decodes the messages and puts them out on an LCD text display. So you could have, say, a Netduino Plus getting tweets from the internet, blinking them out in Morse code, and then another Netduino sensing those via a light sensor and printing out the text to a display, which most people would say would be completely pointless. But he had so much fun building it. You could see his joy in his posts on the website. Other community members have created their own traffic lights. Community members have created music players, which take Super Mario Brothers theme and play it out. RFID reader apps, which can sense your car pulling into the garage or the distance of something. If you look at the forums, you'll see a colorimeter that was created by David Powell from Hartford Hackerspace, a local maker group down in Hartford. And it senses the color of something you put in front of it and then changes the LED to match. Chris Cito created a self-driving car. It's a little model car, although it's pretty powerful, which uses this really rich GPS library, gyros, accelerometers, and it can navigate itself through different mazes or in its own location.
Wow. Okay. What's the biggest project that's been made as far as like the most sophisticated? Have any projects snuck up on you where you said, "Wow, this guy came out of nowhere with this"? Giant, complicated thing.
Yeah, I would say that people who are putting Netduinos in balloons and sending them up with camera shutter timers and GPS receivers, or people who are creating the self-driving car like Chris Sato's RAR, I think those are probably on the most sophisticated ends. The simpler ones, the breathalyzers and the Morse code decoders, are a lot of fun, and some of them are quick and some of them are not. But the really rich ones with GPS and sensors and communication between multiple Netduinos via Zigbee, those are really impressive. And what's crazy is they've been put together in a matter of days, some of them.
Now, you just used a term called Zigbee. Can you explain what that is?
Yeah, so Zigbee is a wireless protocol. Think of something like a wireless serial port, except it can bounce between devices. So you're not limited to just direct range. You can have a bunch of devices talking to each other that repeat through each other. And there's an XBee shield. XBee is a brand name for the Zigbee protocol. You can plug into a Netduino, and then you can talk between multiple Netduinos wirelessly. So you can have a small army of swarm bots which communicate and dig into rubble at a disaster site, take photos of people, and relay back their coordinates. It's really crazy stuff.
Oh, wow. So it's a wireless serial port. It's as simple as talking to a serial port.
It's a wireless protocol. It can represent a serial port. You could do all kinds of things with it, but most people just use it as a serial port.
Oh, wow. Okay. Most people who are listening probably took some hardware classes in college, but they may have forgotten a lot of that. And I find that when I'm doing hardware that's not Netduino related, I'm thinking about voltages and resistors, and I get the old multimeter out. How much time do I have to spend in this environment thinking about things like that, lower level stuff? Or can I build a project without ever getting my multimeter out?
A lot of our users do not have multimeters. We don't list it on the standard list of what you need to use a Netduino. That said, having advanced tools like a multimeter, which aren't terribly expensive, is a really great thing to have. Your best resource, honestly, is the Netduino community. You go to the Netduino website, click on community, and there are hundreds of people who are chatting about projects that they're building, growing to thousands, actually. and they'll help you. If you have a question, they can actually teach you about electronics. There's tutorials online. There's tons of C# code out there. It's really easy to get into this.
Okay, well, that's cool. Well, I know that Pete Brown and I have been having a lot of fun playing with this. And ultimately, it's just trying to figure out what we want to do. Just trying to think about the possibilities, you know?
Yep. Have I given you some ideas here?
You have. I've got this arcade machine that I built a while back, a retro arcade, and I never hooked up the coin slot. I never hooked up the quarter slot. So I was trying to figure out what I could build that would do something cool, maybe keeping track of how many coins are in the slot. Maybe build it with one of my sons and see if I could get this 30-year-old hardware to hook up to the brand new hardware and then register that a coin has been entered in.
Yeah, absolutely. And if that coin slot has a sensor which sends a voltage signal or changes a analog sensor whenever a coin goes in, you can interface that with the existing .NET Microframework. You don't need anything extra.
So I wouldn't need. I would make a driver for my 30-year-old coin slot thing that would probably be just talk to this pin and listen for voltage.
Hey, we love old technology. Someone created an Etch-a-Sketch project using .NET Microframework that you put in a drawing and it actually turns the knobs. It's amazing how you can take the old technology and the new and just mash them together.
Very cool. Well, thanks so much for coming on the show and sharing that with us. And when can we get more information about the Netduino Mini?
So the Netduino Mini will actually be live in the next few days on the website. It's shipping next month. A number of resellers will be taking pre-orders on it, but all the specs are on the website at netduino.com/Netduino Mini.
Cool. And then I would also encourage folks who haven't heard already to listen to the show with Colin Miller. It goes into more detail about the .NET Microframework itself and what's going on at that level. And that you can see at, I think it's netmf.com.
Absolutely.
Thank you so much. And this has been another episode of Hansel Minutes. And we'll see you again next week.